All right, so today we're covering chapter 8, section 1. Chapter 8 is our last chapter. We will go back to one section in chapter 7 after we finish chapter 8, but then we're done for the semester. So that's a little light at the end of the tunnel. But now we're getting into periodic functions. So the first thing that I'll mention is just what is a period. And a period is the shortest time to complete a cycle. Okay, and when we're talking about periodic functions, there's a couple numbers that we're really interested in. One is the period, like I just said, the shortest time to finish a cycle. The next is the amplitude. And we could find the amplitude by taking the y max minus the y min and dividing that by 2. Another important value is the equilibrium. And we find that by taking y, this is going to be, the equilibrium is y max plus y min, divide that by 2. And then we have the midline. And it's important to notice that it's a line, so we have to have y equals, and it's going to be y max plus y min over 2, or y equals the equilibrium. Okay, so essentially, like I said, the period is the shortest amount of time to complete a cycle. The amplitude is, well, let's say it this way. The equilibrium is the point between it's the average between the highest and the lowest point. So your midline is going to be the point, your midline is the line where it's consistently the equilibrium. And then the amplitude is the distance from the midline. Okay, does that make sense?
Yeah.
Okay. So for problem 1, we have to determine whether each function graphed below is a periodic function. And if it is, we have to determine the period, approximate the amplitude, midline, and period. Oh, oops. I read that wrong. But all right, so this first one here, this one is a periodic function. The same exact thing keeps happening. So it's a cyclical function. The same thing keeps happening. We can predict that right around here, we're going to have another peak right around here, and then we'll have another lowest point. All right, so part A is periodic. Okay, so our period is about, and some like to measure from peak to peak. What is this distance? That's a great way to do it and works most of the time. And this one, it's a little tough because the peak isn't necessarily on an easy value.
Excuse me?
So I'm going to go ahead and say, let's just measure the period from where we start. So we start about here, and it finishes right around here. And essentially this part here that I'm boxing, you could almost like screenshot it and then lay it over the next section, and it should match up perfectly.
Excuse me?
Yep.
What if we're on loose leaf? Do we have to draw these graphs?
No, you absolutely do not have to. Just write, A, periodic, and then write all the information next to it. You don't have to draw these. Good question.
Okay.
I'm just a little confused with the like how I got the periodic, but how did you determine that as periodic?
Okay, so determining that it's periodic, it'll be easier, I think, once we get to an example that's not periodic. It'll make more sense, but it's the same exact thing happening. So this part here is happening again here, and it's the same distance apart.
Oh, okay.
And
Thank
you
you.
could tell, like, now we could predict that going in the negative direction and further in the positive direction, the same thing will keep happening. Does that make sense?
Yeah, thank you.
Okay. So this period is the amount of time it takes to complete a complete cycle. And that's about 3. It's about 3. Next, we have the amplitude. A, it's about equal to the Y max, which is 1, Y max. The Y min is here, which is about, I'm going to say 0.25. So 1 minus, sorry, negative, minus negative 0.25 divided by 2 is equal to 1.25 divided by 2. I guess I'll do this down here. A, so I said the period is about equal to 3. The amplitude is about equal to 1 minus negative 0.25 divided by 2, which is equal to 1.25 divided by 2. 1.25 divided by 2 is about 0, or it is exactly 0.625. So that's your amplitude. And your amplitude is the distance from the midline to the peak. And then we have equilibrium. Oh, I guess we don't have to find it, but we kind of have to. So we'll find it anyways. Equilibrium is about equal to equilibrium is about equal to 1, now it's plus negative 0.25 divided by 2, right? The Y max plus the Y min divided by 2, which is equal to 0.75 divided by 2, which is equal to 0.375. Now our question doesn't ask us to find the equilibrium, but the equilibrium is helpful when we're trying to find the midline. So the midline is Y equals the equilibrium, which is 0.375. Okay, so at 0.375, essentially what's happening here, I guess we'll say this is about 0.375 here. Y equals 0.375. This is your midline. Okay, so the amplitude is this distance. That's your amplitude. And then the period, as mentioned before, is the distance to complete a whole cycle. Okay, any questions there?
So the equilibrium is basically the same thing as the midline.
Yes, except the midline is a line, so you need Y equals.
Okay.
And
Thank
it's
you.
found the same way, yep. Okay. Graph B down here, this is not periodic. And we know because this highest point, this peak here is at 4. This peak here is a little below 4. This peak here is even further below. This peak here is even further lower. So it's actually, the peaks are trending downward or closer to 0 on both sides. So it's not periodic. Does that make sense as to why it's not periodic?
Yes.
Good. Graph C, this one looks funky, but all of our peaks match up. and everything in between is pretty much the same. So we say that this is periodic, and each period ends, oops. There. I've just boxed the first cycle. So for graph of C, the period is about 6. From the start to here, it's about 6. The amplitude is about equal to our max. What did I say it was before? Is about 1.5. So max is about 1.5, and our min, the lowest point, is about negative 1.5. So our amplitude is our maximum, which is 1.5, minus our minimum, which is negative 1.5, all over 2, which is equal to 3 over 2, which is equal to 1.5. Okay, that makes sense. And you'll see more why after. And then our equilibrium is about equal to, we need our max, which is 1.5, plus our min, which is negative 1.5, all over 2. 1.5 plus negative 1.5 is equal to 0. So our equilibrium line, or our midline is y equals 0. So our midline is here. Y equals 0 is our midline. So it makes sense that our amplitude is 1.5, right? Because in both directions, we're going from the midline, which is at y equals 0, to 1.5 in order to get to our highest and lowest peaks. Any question there? Okay. D is not periodic. This one's kind of hard to track. You might think at some point that, something has to be repeating. But if we just pay attention to our highest peaks, none of them are the same. So there's no point where we're repeating a cycle. E is not periodic. Even though all of the peaks are the same height in the positive and negative direction, the period length, so the amount of time it takes to finish a complete cycle, is changing. So it's not cycling through at a consistent rate. So it's not periodic. And lastly, F is periodic. Okay, so F here. So F is periodic. The period length, if I start here, if I look here, and we want to get to where we finish there, so I'll draw a line. The period length is about 1.5. Next, we have to look at our amplitude. Our max is 4, so 4, and our min is negative 2. So 4 minus negative 2 divided by 2 is negative, not negative, 6 over 2, which is 3. Our equilibrium is 4, our max, plus our min, which is negative 2 divided by 2, which is 2 divided by 2, which is 1. So our midline is the line y equals 1. So again, our midline is here, is y equals 1. Y equals 1. And our amplitude from 1 to 4 and from 1 to negative 2 is 3. So our math makes sense. Any questions there? Okay, we'll move on then. Problem 2. So now all we have is 2 word problems to apply what we just learned. Excuse me. Each day the tide in a harbor continuously goes in and out, rising and lowering a boat anchored there. At low tide, the boat is only 2 meters. At low tide, the boat is only 2 meters above the ocean floor. 6 hours later, at peak high tide, the boat is at 20 meters above the ocean floor. 6 hours after high tide, after peak high tide is low tide again, and it continues. Suppose that the boat is at high tide at midnight. Part A, sketch and label a periodic function modeling the boat's distance above the ocean floor as a function of time, t hours since midnight. Okay. So we have t in hours and d of t in meters. Here's the point 0, which remember is midnight. Important measurements are every 6 hours for t, so we'll do 6, 12, 18, 24 on our t-axis, and on our d of t on our y-axis. Important values are 2 in 20, so I'll put 20 here, 10 here, 5, 15, 1, 2, 3, 4. Okay. So 2 is here. All right. So, and we know that at midnight, suppose that the boat is at high tide at midnight. So at midnight, we're at 20. And then 6 hours later, we're at low tide, so we're at 2. And if I just draw a dotted line, excuse my not straight lines. If I draw my dotted line, then after we reach low tide at hour 6, hour 12, we'll reach high tide again. Then at hour 18, we'll be at low tide, and hour 24, we'll be at high tide. So we could connect our graph like this. And it's supposed to be perfectly symmetrical and the same continuing, but you guys get the point. Any questions on part A?
Could you go over how you got the points one more time? I'm sorry.
Yes. So at first we're told that the boat is at high tide at midnight. And this problem tells us that high tide is 20 meters. So I know to put my dot here. And then we're told 6 hours after high tide, it's low tide. And at low tide, the boat is only 2 meters above the water. So low tide, we're here. We're at 2 feet, 6 hours later. And then from there, it's a periodic function. So 6 hours later, we're going to be at high tide again. So we go all the way back up to high tide, and we're at 20 feet or 20 meters. And then 6 hours after high tide, we'll be at low tide. So at hour 18, we'll be at low tide, which is 2 meters. And then 6 hours later, again, we'll be at 24 hours and 20 meters at high tide. Does that make sense?
Yeah, thank you.
Yep, no problem. Okay, part B, identify the period, amplitude, and midline of the periodic function. So the period, the time it takes to get from peak to peak is 12 hours. The amplitude is the max, which is 20, minus the minimum, minus the min, which is 2, all over 2. So 18 divided by 2, which is 9. So that's our amplitude. Our equilibrium point is 20 the max plus the minimum, which is 2, divided by 2. So we have 22 divided by 2, which is 11. So then our midline is y equals 11. So the point 11 is probably around right here. Y equals 11. Good. And we go from 11 to 2, that's 9. And from 11 to 20 is also 9. So that's our amplitude makes sense with our midline at 11. Any questions there? Okay, moving on to the last problem. You decide to ride the Ferris wheel at a local carnival. You are 3 feet above the ground at the bottom of the Ferris wheel and 28 feet above the ground at the top. It takes 8 seconds for you to reach a maximum height from the minimum height, and 8 seconds to reach the minimum height from the maximum height. Suppose you're at the bottom of the ride at t equals 0 seconds. Part A, sketch and label a periodic function modeling your height at the above the ground t seconds after your Ferris wheel ride. So we draw our graph, and we have t in seconds on the x-axis, and the y-axis is h of t in feet. Okay, so and really the only 2 points that are valuable on the y-axis for us are 3 feet. So we'll say it's like here. 3 feet and 28 feet. I'm not going to draw the other points in because that's going to just clutter it. And then it's every 8 seconds that we either go from the top to the bottom or the bottom to the top. So we'll have 8, 16, 24, 32, 40. Okay, I'll draw my lines across where my maximum and my minimum are to make it easier when we draw points. So now we're told that we start at the bottom of the ride, which means we start at 3 feet above the ground. 8 seconds later, we're going to be at the maximum. We're going to be at the top of the Ferris wheel. So 8 seconds later, we'll be at 28 feet. 8 seconds after that, we'll be at the minimum. 8 seconds after that, we'll be at the maximum. 8 seconds after that, we're at the minimum. And 8 seconds after that, we're at the maximum. So if we just connect these, again, mine's definitely not a pretty graph. I don't expect yours to be perfect either. As long as you have the important points. And that's our periodic function modeling this situation.
Excuse me?
Yep.
So would they ever give us a word problem like that and it be not a function, not a periodic function?
I don't think so.
Okay.
That'd be kind of mean. Yeah. All right. Problem B, or part B. Identify the period, amplitude, and midline of the periodic function. So our period is 6 from, we could do from the lowest peak to the lowest peak is 16 seconds. Our amplitude is the max, which is 28, minus the min, which is 3, divided by 2, which is 12.5. Our equilibrium is 28 plus 3 divided by 2, which is 31 divided by 2, which is 15.5. So our midline is y equals 15.5. Our midline is, let's say, about here. And then so that means that the amplitude is 12.5 feet and 12.5 feet. All right, any questions on any of this? If you have no questions, you are free to go for today. I will see you on Wednesday.
Thank you.
You're welcome. Have a good day, guys.
Thank
you.
you, you too.
Can you go to the first 2 pages, please?
Here's the first page.